Okay, this is part 2, or part B of exercise 2 on page 96 in our workbook. Okay, and the instructions for this problem are, again, they're giving us a series and asking us to determine whether it converges or diverges. This is another question of the type where we have to kind of think about all of the series convergence tests that we have and pick a good one to use. All right, so I'm going to use the same kind of step-by-step process of working through our tests and seeing if we can identify a good one here. Okay, so we might start with the test for divergence and try that, since that's sort of at the beginning of our list. Would that work? Okay, well, let's see. If we take the limit as n goes to infinity of 2 to the n over n times 3 to the n, we could rewrite that if we wanted to like this. The 2 and the 3 are both raised to the n, so we could maybe consolidate them, okay, into just one fraction raised to the nth power. That's just another algebraic way of writing this. And then the question is, what happens as n goes to infinity? Well, the 1 over n piece, that's going to go to 0. And if you think about it, 2/3 to the n, that's also going to go to 0. Because 2/3 is a number that's less than 1. If you raise a fraction, something that's less than 1, to bigger and bigger powers, it actually gets smaller. Okay, so this limit is going to be 0. And as we observed in the previous example, that doesn't help us. Getting 0 is inconclusive when we're using the divergence test. Okay, that's okay. It just means that we need to go down our list. Okay, and if you go a little bit farther down your list, you come to the ratio test. Might that work for us? Okay, well, it kind of looks promising looking at our series itself, because we've got constants raised to the nth power. 2 to the n is a constant raised to the n. Generally, when you see something like that, there's a good chance that the ratio test is going to work for you. All right, so let's try it out. Okay, so the ratio test involved taking a sub n plus 1, and remember, an is just our name for the term that's in our series. So an plus 1 would be like taking that an and just putting in n plus 1s everywhere that we see an n. Okay, so all of that we just wrote down is an plus 1. And then we need to divide by a to the n, okay, which means we're going to multiply by the reciprocal of an. That's going to be taking the an that's up here at the top and just flipping it over. Okay, oh, and one thing you might have noticed that I did not do quite right. We need absolute values when we use the ratio test. Okay, so we'll rewrite it like that. Okay, and the first step in a ratio test always looks a little bit ugly, but what we're hoping for is some cancellation here. Okay, so is there anything that might cancel for us? All right, well, just to make it easier to see what cancels, let's rearrange things a little bit. So in the top, we've got a 2 to the n plus 1, and in the bottom, we have a 2 to the n. Let's maybe write those over the top of each other. Okay, then we could group the 3 to the n over 3 to the n plus 1 together. And then finally, we've got an n over n plus 1. All right, and what we're looking for is cancellation. Notice that there is a little bit of cancellation. So 2 to the n plus 1 over 2 to the n, if you subtract the exponents, you get a 2 in the top. Another way to think of it is that there's one extra 2 in the top because the power is one bigger. Okay, and same idea over here with 3 to the n over 3 to the n plus 1. We've got one extra factor of 3 in the bottom, which means we're going to have a leftover 3 in the bottom after we cancel. Okay, and then we come to the n over n plus 1. Can we do any cancellation there? Okay, it's tempting to cancel the two n's, but we can't do that because of the plus sign that's sitting there. It wouldn't be algebraically legal to cancel the n, so we kind of have to leave that the way it is. All right, so we've done all the canceling we can do. Let's rewrite what we've got. So we've got a 2 and an n left over in the top, and in the bottom we've got a 3 times an n plus 1. That's what we need to take the limit of. And notice that I dropped the absolute value signs. We can get away with that because everything is positive. Okay, maybe rewrite that one more time by taking that 3 and multiplying it through. Okay, and there's a limit that has the form infinity over infinity, so we can use L'Hopital's rule on it. All right, so derivative of the top is 2, the derivative of the bottom is 3, and that gives us a final answer for the limit of 2/3. Okay, we're using the ratio test, so we have a name for that number. It's called r. Okay, so does that allow us to reach a conclusion? Well, you can look back at the ratio test a few pages ago in the workbook and see that it does. If r is between 0 and less than 1, the ratio test tells us that our series converges. Okay, and so we can go ahead and write a proof, and it's going to be a pretty short proof for the ratio test. All we really have to mention is we calculated r, got 2/3, notice that that's less than 1, and that fact alone is enough to tell us that this series converges. Okay, and with that we are done.